Hello, I am Michael Woods, the Chief Scientist at the Asian Turfgrass Center. This is the ATC Double Cut, where I talk about some of the content that's been on the ATC website, something that I've written about, and then I talk about it. And today, I am excited to have a special guest to join me to talk about a post that I wrote called The Most Common Soil Testing Mistakes and How to Avoid Them. My guest today is Doug Soldat, the professor and turfgrass extension specialist at the University of Wisconsin-Madison. Welcome to the ATC Double Cut, Doug.
Thanks, Micah. Great to be here. Good to see you.
It is good to see you. It's been a couple of months. We met earlier this summer in Copenhagen, Denmark, at the International Turfgrass Research Conference. And we talked about this kind of stuff because every time we meet, we often talk about turfgrass nutrition and soil testing. And in fact, you joined me on the ATC office hours episode earlier this year when we talked about tissue testing, which maybe we'll talk about a little bit today. But I thought it would be great to talk about soil testing because I was looking through my website, which has a lot of posts on it. And the post that I came across as we come into autumn, which for me is the ideal soil testing season for, I mean, at least if you're in the Northern Hemisphere and if you're in a part of the world where it rains throughout the year and you have that case, I like to do soil testing in the autumn, preferably if you're only going to do it once a year. So I'm looking for things that, making sure that people are going to take the samples properly and make sure that they don't make any of these mistakes. And I realized, I think I've got a blog post. I think Doug's written about this. And so I found that blog post, and it's all about, it's quotes from you, from that article that you wrote back in 2013. So I thought, let me contact you. I'll send a tweet and tag you in it and see if you will join me on the ATC Double Cut. And you gave a thumbs up to that. So thank you. I'll bring up let's see. First, if anybody doesn't follow Doug on Twitter, he is at DJ Soldat. That's your Twitter handle. And you don't tweet too often. So it's a great follow because when you do, they have a high impact and you tweet some amazing photos that are often related to nutrition, weird things that we see related to deficiency or diseases that happen or don't happen depending on which nutrients get applied. So I highly recommend following Doug on Twitter. That's at DJ Soldat, DJSOLDAT. And
Yeah, I won't be clogging up your feed, that's for sure.
Yeah, you won't
expect tweets quarterly. Usually
quarterly, but when you do, it often will start a big conversation, or it's certainly something that's meaningful. So I'll put links to Doug's account on Twitter, and I'll put a link certainly to this particular blog post that we're talking about today to start our conversation, which is the most common soil testing mistakes and how to avoid them. And this is a post that I wrote many years ago when I updated it earlier this month. And I said, one of the columns I've really enjoyed reading is the Wisconsin Soils Report. And I put a link to it, to an article that you wrote in the May-June 2013 issue, where you asked the question, how reliable is soil testing? And you started off, and I've reread that. I don't know, did you reread that article recently?
I haven't reread it recently, no.
Okay, so I'm going to put up a ticker that shows the O.J. Knorr quote that you kind of started off with, because you said there are a number of soil testing mistakes, and in the article you were going to try to explain how people could avoid them, and then you jumped into this quote from O.J. Knorr, which he wrote in 1928, and that's playing on the screen if people are watching this. And I'm going to read it for those who are listening. Or maybe since you wrote the article, Doug, let's wait till this restarts on that
Yeah,
banner, and then we'll let you read it
you
in
know, I
your
actually don't
voice.
even have to. I don't even need the script because I've said this so many times that
Well, why
that
don't
I
you
have it
paraphrase?
committed to memory.
Go for
But
it. Go for it.
so OJ Noor. So the backstory on this a little bit is OJ Noor had expertise in soil testing. So he was a Wisconsin graduate. Um, and his major professor was Emil Truog, who invented the do-it-yourself home pH kit. And his specialty was soil testing. And there was at one point there was a soil test called the Noor extractant. So OJ Noor had his own soil test extractant. So this is somebody that knew a lot about soil testing. He was also the director of the Wisconsin State Soil Testing Lab. So this quote says that there's a tendency to place too much emphasis on the value of soil testing, coming from the person that studies soil testing. And he says this is true of everybody. So technical workers, salespeople, and then he says back in 1928, these methods have a promising future. So he saw the potential in it, but presently the usefulness is limited by imperfect methods, meaning extractants, and for a lack of definite correlation with field experience, which is a mouthful, but basically means you need to have good research data to interpret those numbers. And at that time, he wasn't confident in the research calibration. So there's two aspects to it. Is the extractant telling you something meaningful? And at that time, OJ said no, and that's partly why he developed his own extractant to try to improve that. And the second part is soil tests are only as good as the data that you have behind them. So a lot of times when I talk about soil testing, we say, well, let's take a look. That was 1928. Where are we in 2022?
And in the article, you divided that into three. So, in addition to the imperfect methods and the lack of correlation with field experience, you also highlighted the undue emphasis and explained that we can't put too much emphasis on the results and don't try to hit certain target numbers and don't try to balance all the cations and stuff like that. That's not really how to use soil testing. So we can talk about this quite a bit. I suppose you know another quote. When I read that, I thought of the quote by Bernard Dyer from 1894 that I stumbled across when I was a graduate student, and I always thought that that was an interesting one that also just kind of says that soil testing isn't everything it's cracked up to be. So, if you don't mind, I'll play this one too on a banner at the bottom of the screen. Dyer was a chemist, I presume, in the UK, and he wrote this in the Royal Society Journal of Analytical Chemistry in 1894. And he said on the analytical determination, well, the title of the article was on the analytical determination of probably available mineral plant food in soils. He wrote that in 1894. And he said, the chemical analysis of soils, which in the early days of agricultural chemistry was looked upon as likely to be of very great practical use in agriculture, was soon found to be, as ordinarily practiced, of very limited value. I've mistyped that. I think I typed it as an or very limited value. It should be an of very limited value. I thought that's very funny because he wrote it in 1894 and he's already referring back to the early days of agricultural chemistry. But from our current viewpoint, we would look back to that as the early days of agricultural chemistry. And that basically is the same kind of thing that Noor was saying in 1928, which is there. We think that we should be able to do a lot with soil tests, but back then they couldn't. Now I'm much more optimistic about what we can do with soil tests today. However, you can certainly get it wrong, and unfortunately, I think a lot of people do get it wrong, and we don't know everything, but we can give our best advice about how to make use of soil tests. So I think, Doug, I would appreciate if we can try to identify or discuss some of those common soil testing mistakes that you wrote about in the article, and then suggest how in 2022 or in 2023 we would recommend making use of soil testing if you're going to do that. Now, I did reread the article and I made some notes about the things that you highlighted as some of the most common problems. One of them is sampling depth, which I think is critical, absolutely critical, and especially for phosphorus, but for everything that you measure is going to be influenced by the sampling depth. Why is that?
So, and I agree 100%. If you're gonna take soil samples, you're gonna have to take them to a specific and consistent depth. And this is more important in turf grass systems than it is in other agricultural systems where the soil's mixed occasionally through tillage or incorporation of nutrients. So in turf systems, we put all our nutrients on top, and what that results in is what we call, fancy word, stratification. But basically, you just have more nutrients at the top, and they decrease as you go deeper. So you notice this in. Yeah, I've received emails and phone calls from people saying, like, I haven't applied phosphorus in a long time, and I just noticed that my soil phosphorus levels just went way up. And although you can't prove it with 100% certainty, but it's almost positively because their samples that they submitted were shallower. So if I take a sample to 1 inch, I might have a soil phosphorus content of 100 parts per million. And if I go down to 2 inches, it might be 60. And if I go down to 3 inches, it might be 30 or 40. So then you have three different numbers, very, very different numbers, dependent, that are just reliant on how deep you go. So the solution to that is just pick your depth, be consistent. I used phosphorus as that example. It's the most extreme case, but you also see that with pH. You'll see it with potassium, calcium. All the nutrients that we apply that are retained by soils typically have higher concentrations near the surface than they do down deeper.
Yes, because you'll have more organic matter near the surface. So if you've got a sand root zone, much of the cation exchange capacity, much of the storage of potassium and calcium and magnesium and so on is going to be where there's more organic matter in the soil and there's more organic matter near the surface. So just the way that it works, whether you're dealing with a nutrient that is relatively immobile in soil. Well, I just cut out there for a minute, so that was a bit of a technical problem, but I'm back talking about the importance of depth. And I was just saying that with organic matter, that has some cation exchange capacity. So you'll have cations that are more concentrated closer to the surface too. And I just encourage anybody that's collecting soil samples, pay special attention to how deep you go. I can't really overstate how important that is, because the idea of soil testing is to identify deficiencies or to make fertilizer recommendations. And we want to make use of the numbers. And if we're going to make use of the numbers, it's essential that we have as accurate results as possible. So
How do
for
you,
me,
Micah, how do you choose that depth?
I stick to 10 centimeters, which is 4 inches, which is the number that I like for convenience, and because I think for a lot of turf grass sites that is a depth where you have roots. Okay, so I know, like in New Zealand, it's standard to use 7.5 centimeters. So if I was in New Zealand and, their calibration work is done on 7.5 centimeter depths and everybody else is doing it 7.5 centimeter depths. So if you're in a part of the world where everybody's using a different depth and you have data that's calibrated to that depth, then I recommend that's a good reason to use that other depth.
Right.
If you're in a particular state and your state laboratory tells you please do it at 6 inches, and that's what you're supposed to do, and you're using that lab, then that would be another good reason to do something like 6 inches, which would be 15 centimeters. But if otherwise, like we did MLSN based on 10 centimeters, 4 inches, and it's a number that I like. And some people say their roots never get that deep, and I say, but yeah, but maybe they could. Let's be aspirational. So, I I like it, and it's convenient because it forms in 1 square meter to 10 centimeter depth. That's 100 liters, which is convenient for a number of things. But certainly, you just multiply the bulk density times 100, and now you know exactly what the mass is. So you can. It's nice to do the math when you have a 10 centimeter depth. Also, what do you recommend in the article? I think you said 3 or 4 inches, or 4 or 5, something like that. But
Yeah, we do a lot of our research that we've done has been on 7.5 centimeters or 3 inches. Um, and I think our soil testing lab will say 4 to 6 inches, which is 10 to 15 centimeters. So you're going to find variability. But I think the most important thing is that you pick a convention, 7.5, 10, 15, whichever you feel is most applicable, and just make sure you keep that consistent. Don't do 3 1 year and 4 next year, or 7.5 centimeters 1 year and 10 centimeters next year. Just pick your depth. I've a good tip I've heard from practitioners is that they actually put a stopper on the soil test. So it's your green sampler, it cannot go deeper than 10 centimeters, for example. So you push it into that stop. They have a lot of probes have marks on them. The marks are hard to see. If you put a Sharpie on there, it'll wear off. I've used a piece of duct tape before, but have a robust system so that you can be consistent with your sampling depth.
yes, I think we cannot overemphasize that enough. That's really key. Now, the one thing I would say is if you've been sampling to 2 inches and you don't, but your roots are down to 4 inches, or if you've been sampling to a foot, like if you think you've been doing it a little bit uh, less than ideal in the past, you can just change. At some point, you could change to a reasonable depth and just going forward, sample it at a proper depth. But because I'm sure there's some people out there sampling to 8 inches or something that maybe that would not be ideal. But basically, yeah, pick a number and stick to it. So you you also recommended sticking with the same lab, and that is very important because what you mean by lab basically is extraction method, because people don't understand how many different extraction methods there are around the world, and different labs do different extraction methods. So if you send your sample to a lab in New York or something, they may use sodium acetate to extract your potassium or extract your phosphorus or something. But then if you send it to Brookside Labs, you're using Malic 3, which is not sodium acetate, and you'll get a completely different number. And that that's the issue when you send samples to different labs and you don't really specify what extraction methods will be used. So the
Yeah, that's correct.
So the idea is if you're sending to the same lab, then the numbers are comparable, which goes back to why we were emphasizing the sampling depth being so important, because we want to compare the results over time, which we will talk about why that is so useful a little bit later,
And
I think.
there's even another layer to sticking with the same lab. So let's say there's two labs that use the Malic 3 extraction. I would still prefer that you stick with the same lab that's doing that Malic 3 extraction that you've done for years, because believe it or not, there are slight differences in how those samples are processed. And for example, you can analyze the phosphorus content using a machine called ICP, or you can do another method called colorimetric, and they're going to give you slightly different results. Um, the way that the lab chooses to grind and sieve the samples may influence the number. So there you will see some level of variation even with the same extraction when you switch labs. So to be one of my favorite things about soil testing is tracking nutrient levels over time to look for trends up or down or stable. And the best way to do that is to stick with the same lab and the same extraction and the same depth. Just be very consistent in those methods.
Exactly. The things can differ a lot, and even between different labs, they'll scoop different amounts of soil. So everybody basically with Malic 3, I think it's generally a 10 to 1 or 1 to 10, 1 part of soil, 10 parts of extracting solution. But some labs will do that with actually 1 gram and 10 milliliters. Others will do 2 grams of soil and 20 milliliters of solution. So they have the same ratio, but it's a different soil volume. So there's all kinds of different different procedures that you may not know about, but you can expect that the laboratories, for any one laboratory, they should do it the same year after year after year. So that makes your results comparable, which is what's really important, because you want to see if nutrients are going up, going down, or staying the same. So that is easy. Another thing you said is don't over interpret the results. That's you wrote about that in the article, which I think is kind of the meat of this conversation. Is how to make use of the soil test data, and how should we interpret it, because I I think that it's possible to adjust fertilizer inputs based on the soil tests, based on the results of the soil test. But you, I don't really think there's ideal numbers that we're shooting for. And traditionally, the way that soil test reports have been reported, you don't really get a timeline trend. You don't get a historical record of your own data on a soil test report generally. Now, I do that. And in fact, I've got a new kind of secret soil testing newsletter, which I finally got started with this year. And I've been sending this, I call it secret because it's really just for the ATC soil testing clients. But that is at subscribepage.com/soil. I'll put a link to that. So in that kind of, well, anyway, for my soil testing clients, when they get a report, if they've tested with ATC before, they get a historical record going back to the last 5 samplings or so. And we're not really trying to look at ideal numbers. We're just looking at whether the phosphorus is going up or down, whether it's above or below the MLSN guideline, and so on. But what you would typically see on the average type of soil test report that you'd get from most commercial laboratories is a classification of every element as low, medium, or high based upon how the results came back on this particular day. And it's not looking at how it's been changing over time. And then you have to consider what justification there is to call something low, medium, or high, which that generally is not very accurate. It's not generally a very accurate interpretation of what actually really is low, medium, or high. So I think you can sample perfectly, and you can send consistently to the same lab over and over. But if you overinterpret the results based on your grass being fine, but you're going to believe that you're low in something or high in something, and that might be a problem just based on looking at a report. That I think that's what you mean when you say don't overinterpret the results.
Right. Yeah, the GCSAA did a series of surveys about resource use, and one was fertilizer use, and they asked respondents to answer a series of questions and then report their nutrient use. And one of the things that stood out to me on that report was that people that soil test use more nutrients than people that don't soil test. And the irony is in the educational world, we have a lot of cute phrases like "don't guess, soil test," or "soil testing is responsible." You know, it's a responsible practice for minimizing nutrient use. So the idea that don't apply something you don't need. So how can it be that the people that soil test actually apply significantly more nutrients than people that don't soil test? That should be completely backwards. And the reason for that is the interpretations are bad or based on irrelevant data. So the point of soil testing, or the interpretations, if you're low, medium, and high, is how likely you are to get a growth response to an application. Or it might be how likely are you to achieve a return on investment for that phosphorus or potassium application. And those concepts were developed in agriculture. They basically don't apply to turfgrass. And the soil testing guidelines that many people use are usually derived directly from agricultural production. Now, that's not always the case, but that is where things started. Um, so the point is, the reason for this is that if your soil test says you're low in potassium or low in phosphorus, most people's inclination will, well, I better go put some out. But the chances that you actually are seeing a phosphorus deficiency or a potassium deficiency that would give you a growth response are actually really, really low. The MLSN set of guidelines, I think, move us closer to what you'll see. Like, how likely are you to see a response? But if you're following these old agricultural philosophies of soil testing, you're going to end up spending more money on fertilizer, and I don't think you're any more likely to see a growth response than if you didn't apply those nutrients.
Yeah, I agree, and you can end up you can end up applying way more fertilizer trying to hit these numbers because we often grow turf in a sand-based root zone that doesn't hold so many nutrients. So you saw that recent research from Michigan State University and Jackie Guevara and Kevin Frank, where they'd applied, it was something like about 4 times as much potassium over a 2-year period. And so that was trying to hit the SLAN, the sufficiency level guidelines from, I presume, from Michigan State University or from the state. And they applied 4 times more potassium by that interpretation method than they did by the MLSN calculation, and the turf quality was exactly the same after 2 years, and the soil test potassium was exactly the same after 2 years. So all that extra potassium they applied was just gone. Now I understand that they've continued that study another year and it's ongoing now. So I suppose we may learn more, that maybe eventually MLSN fails and it's not enough, but that's why we test things and see. So, but I don't think it will. I think the MLSN guideline generally is enough. If you follow it so that you keep the soil so that there's always about 40 or 50 parts per million potassium, it's unlikely that that the grass is going to suffer at all. So you also wrote about that. I'm going to go back to scroll through this blog post and highlight 3 things that I put in there that I thought were especially relevant. And, you know, they were relevant back in 2013 when I read this for the first time. And I think they're still relevant today. One thing was about on soil test extractants. You said, while Malic 3 may not be the best test for all situations, and you were talking about different extraction methods, he said Malic 3 may not be the best. It is regarded by many as the most versatile extractant, and it's the one we have the most calibration data for here in Wisconsin, with the Bray coming in a close second. I often get questions about soil test extractants, and in fact, my PhD research about 20 years ago was largely about different soil test extractants for turfgrass. And Malic 3 was not my favorite, but it's the one that I end up using a lot because it is quite versatile and it's used all over the world. And especially it's common in North America where there's so many soil tests done. So I think if you have an opportunity to use Malic 3 and you're not dealing with a really calcareous soil, then Malic 3 pretty much gives you a result for a lot of different nutrients. But I mean, more data than you can make use of, actually. Do
Yeah,
you?
that's right. The the Malik 3 was actually developed to work in many different soils. So before, like a lot of the other soil test extractants that you'll use are going to be regionally relevant. So for example, it says there in the blog post, the Bray is good for Wisconsin. Well, Roger Bray was a soil chemist from University of Illinois and developed a soil test that works really well for Midwestern agriculture. So if you're growing corn or soybeans in the Midwest, the Bray is a great extraction. But
Are
in
you
turf
talking
system,
Bray 1 or Bray 2?
well, I don't want to get into those splitting hairs, but let's just say that Bray 1 and Bray 2 are in the same family of extractions, one stronger than the other.
Okay.
Um, But like for turf grass systems, we're growing sand putting greens in Wisconsin that are also being grown in Maine and North Carolina and Arizona. And the so there's much more variability in climate and soil type. And so the Malik 3 is better works well across those systems. And there's so few people doing turfgrass research on soil test extractions that my philosophy is if we can all use the Malik 3, we'll have a bigger, larger data set. But Bray wouldn't be a good choice for somebody that's working in Utah, but Malik 3 might be. So again, probably into the weeds a bit here, but I just like to tell people if you can get a Malik 3 extraction, I think that's going to give you the most reliable interpretation in
Yeah.
turf.
It is it is a nice test that works well across a wide range of soil pH, which is the main gradient that we would be looking at. It works well across a wide range of soil types. And when we get the numbers back from a Malik 3 test, we generally would look at those numbers and you kind of know what you're looking at. And it's very rare that I would get a number back from a Malik 3 test and think, that's crazy. Yeah, but with some other tests, I often don't even know what I'm looking at, and I have to consult various types of extension publications or some obscure literature of tests that people have done to compare a less common test to something that's more standard. So, Malik 3 is nice. And then another quote from you, which I've used many times when I've given presentations to explain why soil test calibration is never going to be done. You wrote that turfgrass researchers continue to improve the soil testing recommendations, but that type of research, and by that you mean calibration research, basically. You said that type of research is time consuming and expensive. It is also worth noting that every time a researcher conducts one of these calibration studies, they tend to find that the levels required are lower than what we previously thought, meaning that when you got a low potassium on your last soil test report, it might turn out that that classification would be optimum potassium down the road. And I've used that quote many times to say that, especially the part where it says that type of research is time consuming and expensive. And I go on to say that it's specific to a particular grass species growing at a particular geographic location or climate in a specific soil type. And
Mm-hmm.
then you mentioned the broad geographic range of turf grass, and you've got grasses grown on different continents. We're not just dealing with one species either. We've got warm season grass, we've got cool season grass, we've got multiple types of sandy soils and clay soils and lawn soils and even on a particular property you'll have so many different types of soils and different grass types. So the what I always say is all this calibration work that people seem to want, it's never going to happen. It's way too expensive, and it's impossible. So you can't really calibrate soil tests for turf grass the way that soil tests are tried to be calibrated for rice or for corn or for wheat or for other agricultural crops. And because of that, we need an alternative. And that goes on to the next quote where you said you recommend that you compare your results with PaceTurf's minimum levels for sustainable nutrition, or MLSN, and you put a link to that. And the minimum levels published by PACE are drastically lower than many traditional soil test interpretations and likely more accurate. Now, you wrote that back in 2013 when MLSN was just about a year. It was relatively new. It was just introduced. Since then, we've updated it once, and we have lots more research since then that shows that you're pretty safe to be below MLSN. Certainly with potassium and phosphorus in some cases, certainly with bent grass. But you'd think that MLSN is still a pretty safe recommendation, and it gets away from trying to hit these target levels that are based on calibration work that has not been done for turfgrass and will never be done for turfgrass. So that's I the more I work with MLSN, the more the logic just makes a lot of sense to me, because it's quite easy to use.
Right. Yeah, I think the MLSN is one of the best data sets we have for making informed decisions about what to do about a soil test report. Things that, I like to talk about if people are uh, wanting to be more precise with their let's use phosphorus example, with their phosphorus applications. I just recommend not applying it until you see purple. So phosphorus is a very visual deficiency, and it's very sensitive. So I compare it to a light switch often, where if you have adequate phosphorus, the lights are on and things are functioning perfectly, great brightness. And then once you drop below a threshold, the lights turn off, the grass goes purple, and it grows slowly. It doesn't die. It's not. I think people, when I recommend this, they say you're crazy. Your job isn't on the line. It's a very subtle, darkish, purplish coloration, slower growth, not dead at all. I can have a purple looking plot for years and years and still maintain density on it. So when I do this on my research station, I let it go until it turns purple. Then I take a soil sample and then send it off. And often the Malic 3 phosphorus level in the top 7.5 centimeters is in the single digits. The MLSN, Mike, I think is maybe 21 parts per million. And so
That's right.
I usually, or I have not seen a purple stand of grass, a phosphorus deficient stand of grass, anything higher in the double digits parts per million. So like half of the MLSN, and it's usually like 4, 5, 6 parts per million phosphorus. So that's something you could do on your sand root zones to figure out how low can you go, and then that is the number that you need to stay above, for example. And so again, people think, oh, that's nuts because I don't ever want to have nutrient deficient turf. You have nutrient deficient turf right now. It's just nitrogen deficient. And when phosphorus becomes limiting, it turns purple. And so we don't freak out about nitrogen deficiency.
Can you
Um,
just explain, for people who aren't making the connection about why their turf is nitrogen deficient? Can you just explain that
yeah,
it's growth limited, right?
it's growth. So the definition, the agronomic definition of a deficiency is if you add some of this thing, will it grow more? And that's what nitrogen does. We're limiting the growth of our grass by limiting nitrogen. And so we started off. I loved how we started off talking about the classic soil fertility, plant nutrition quotes, and it got me thinking about this other one I use all the time, Liebig's law of the minimum. So Justus von Liebig was a German scientist who developed this barrel analogy where he says the amount of water that a barrel can hold is limited to the lowest stave. So you can think about the plant nutrients as being staves in a barrel. And actually, O.J. Knorr, in his book in 1928, published this analogy. And so in most cases, nitrogen is the most limiting nutrient. If you add more nitrogen, that stave gets longer and the grass starts to grow. And the reason we don't see as many nutrient deficiencies in turfgrass systems as we do in agriculture is because we are limiting our grass already by limiting nitrogen. That means we can get by with even lower levels of the other nutrients. So long story short, you kind of want to figure out where those limits are. MLSN will get you close in the ballpark, but MLSN is not going to push you down
Yeah,
near where
MLSN
your
is
grass is really deficient. It's
yeah
really not the
MLS
minimum. It's like kind
no
of a right.
MLSN is designed to prevent deficiencies. So
Yeah.
it has the word minimum in there, but it's designed to be a safe level. And we called it minimum because it was so much lower than the conventional guidelines at the time. But it is designed to prevent deficiencies, to be a safe way to prevent deficiencies. And we know that it recommends more than is necessary in order to have high quality turf. But because there's no alternative other than kind of figure it out for yourself, and wait until you see a deficiency, that if you just want to put it on cruise control, you can just make sure that you let the soil drop down to somewhere near the MLSN guideline and then just supply the fertilizer to keep it at or above that level.
Right. Yep.
But if you want to really push it, then you kind of cruise down to the MLSN guideline and then you watch the turf carefully, and you also watch the soil test change over time, and then you say, hey, I don't need to add potassium.
Yeah. And that's expert level, right? You have to be comfortable with that. We're not recommending, if you're not comfortable with those things we said, then just do what Micah said. Allow your levels to come down to approach the MLSN and then add nutrients to maintain stability around those levels, and you'll be fine. One of the arguments I heard against MLSN from a superintendent speaking at a conference I was at gave this analogy. Said, "Hey, I flew here in a plane, and I didn't, I hope my plane didn't have the minimum amount of fuel to get here." And everybody laughs and says, "Oh yeah, that's why we shouldn't use MLSN, because it's getting too close to dangerous." And as we just said, that's not how MLSN works. And in fact, I gave you the example that it's basically twice as much phosphorus as my grass requires when I allow it to go deficient. But I told that story to somebody who was a pilot, and they laughed because he said, that analogy is actually perfect, because that's how they do calculate fuel, adding fuel to planes. So they calculate a safe amount, and if you have too much fuel, that's bad too. So they optimize and I'm not repeating this as well as the pilot did. The pilot said MLSN is a great analogy of how they actually pick the right amount of fuel to put in a plane for a trip.
Yeah,
So I got a kick out of that.
yeah. But if I understand that there's a bit of math and a big database involved with MLSN, and not everybody understands how it was actually calculated and what those numbers mean. But if you study it like I have, you realize that it's really safe because we've got all these soils that were producing good turf that were below the MLSN level that we throw away. And we said, that's our safety margin. We're going to make sure that we stay above that. And the implication of that is if you soil test and pay attention to what your nutrient levels are, and you don't jump around sending samples from different depths and sending them to different laboratories and stuff, but if you're consistent, as we've recommended, consistent in sampling depth and consistent in the same extraction methods, consistent with the laboratories that you're using, and not trying to hit target levels in the soil, but just looking at what the trend is over time, then you can make great use of MLSN. And I've got some clients in Japan who've been testing for about 15 years on putting greens, and they've seen it come down from phosphorus from over 300 parts per million down to about 60 or 70 right now. And I know we'll have to apply phosphorus sometime, but I'm quite interested to see how long it will take. And it's great to see that, because when you've got in a sand root zone a 330 parts per million Malic 3 phosphorus, that is a high risk of leaching or runoff loss, which is pollution, and it's not good for the water and not good for the appearance of the water because it gets so full of algae.
And it's a good soil to would might encourage a weed species. Annual bluegrass comes to mind. So if you have a lot of phosphorus, that encourages seedlings to germinate that you may not need to germinate. So there's a lot
Yeah.
of reasons not to have excessive levels of nutrients in your soil.
Yeah. There are a lot of reasons not to, like your potassium research, where you see or you have seen striking differences in snow mold on creeping bentgrass on multiple years based on whether potassium was applied the previous autumn or not. And even at moderate levels, but it wasn't necessary for the grass, but it was the standard thing that we used to do was add a little bit of potassium in the autumn, late summer going into autumn, add extra potassium. Turns out that increases the snow mold. And by doing this kind of research, which you've done all kinds of cool experiments like that, you can discover that, wow, maybe adding fertilizer can be even more of a problem than withholding it. So long as the grass has enough, and it almost always does because we limit growth by nitrogen, not by other elements.
Well said.
So yeah, what else? I I've written a couple blogs about things that are kind of that we haven't mentioned yet that can be problematic. And I'm not, so we've pretty much agreed about everything so far. Now we'll go into the part where we might disagree a little bit. I don't think we've talked about this, certainly not recently. I always recommend drying samples because I want to stop microbial activity as soon as possible. But you have to consider I'm often dealing with samples that are being shipped internationally. So they may be in the mail or they may be stored, or you can't really predict when they'll get there, but it's anywhere from a week to 2 months or something. If you send that sample wet, not only does it cost more because you're shipping water, but you are allowing ion exchange reactions to continue, and you're allowing soil microbial activity and mineralization to continue. Your organic matter is breaking down. Your sulfur is being mineralized. Your phosphorus and your nitrogen are being mineralized to some unknown degree. So I recommend dry the soil samples. The samples will be dried at the lab before they get processed anyway. You might as well just dry it yourself. And I recommend that for everybody. And I think people are too loose with that. They're too, I think they don't think about that. They just take the sample, they may leave it sitting around over the weekend, and then send it off to the lab without drying it. Now, there was an interesting blog post from some researchers at Kansas State, and I blogged about that about a month ago, and they were looking at nitrate specifically, and they doubled. So they did it in a truck bed. They refrigerated the sample, which has the same effect as drying it in terms of stopping or reducing the microbial activity down to almost zero. And then they stored some of the sample in a truck bed. And then they withdrew it after 2 days, after 4 days, after 6 days, something like that. And the amount of nitrate, I think, doubled in 4 days. And it more than tripled after about 10 days when it was in the truck bed. Now, I don't really recommend that in turf grass that we sample for nitrate or that we test for nitrate, because I haven't seen a huge I I used to test for it, but I don't anymore because I haven't been able to make much use of it. And so I would rather save money on the testing costs and just keep it simple. But where's that nitrogen coming from? It's coming from the organic matter. It's coming from the microbial activity that hasn't been stopped. And I wonder how the organic matter is going down. And because the humus, the organic matter in turfgrass soils, especially in sand root zones, tends to be relatively low because of a lot of the top dressing work that's done, and a lot of the sandy soils just don't they don't get so much humus in them anyway. So if we're dealing with a soil that's like 1.2% organic matter or something, and I'm talking about humus here, not the OM246 type of method where we don't remove the undecomposed material, but just talking about the humic material, I want to be as accurate as possible. So I don't want microbial activity continuing. So I like to dry the samples. And that's not going to be as large a source of error, I don't think. I'm almost certain it can't be as large a source of error as sampling depth inconsistency would be. But it is a source of variation. And when I do see some really weird things with the soil pH, or I see weird things with some of the results, I wonder, was that sample dried before it spent 2 weeks in transit to the laboratory? So I don't know how you think about that, but it's something that I recommend is if you want to be consistent, just dry it yourself.
Absolutely, yeah, I agree with that 100%. And as a researcher, that's what we do. We take our samples in uh, usually paper bags, and we leave the paper bags open on a bench. And sometimes we even put them in an oven. If you keep them in a Ziploc bag or a plastic bag, it locks in the moisture. So somewhere even evaporation can dry them down in a couple days if they're left open. Um, and then the other thing we do is put them in the refrigerator or freezer to stop that microbial activity for the same reason. So I think that's great. And especially if I was shipping them, I'd want them dry. It's gonna save you probably half in postage versus wet
It
samples.
Yeah, and it saves you a lot of worry. It certainly it gives you a lot of peace of mind knowing that when you shipped it to the laboratory, when it left your hands, it was already dry. There was no microbial activity, and there was no more ion exchange. Because as you get different soil water content, some of the ion exchange reactions, whether it's divalent cations or monovalent cations, the exchange happens a little bit differently. And I just always worry about that when I see weird results. And so I really encourage people to take the 2 or 3 extra days to just dry your samples before you send them off. And then the other thing that can go way, way wrong is just in the way that the spatial sampling, right?
Mm.
What consists of a representative sample? And I don't think that we can really explore that in the time that we have left in as much detail as it deserves. But there's 2 ways that you can do it. One is to take a representative sample that involves a lot of subsamples. And this is the standard method. This is what's recommended is take a bucket. And most universities for turf grass, the fact sheet about how you're supposed to take a soil sample, it says take 12 or more subsamples, put them into a bucket. So we assume that you've taken all of these at the specified depth. So that's going to be a minimum of 12 samples from the area that you're testing, which might be, if it's on a golf course, we'll say it's green number 1. If it's a football field, we'll say it's from all over the football field. If it's a home lawn, we'll say it's from the lawn. You've taken 12 subsamples at minimum. You're supposed to put them in the bucket. You're supposed to homogenize that sample, mix it up so it's all mixed. But you realize that now we start getting into problems because you've got grass on the sample and you've got roots through the sample. And if it's soil and not sand, it's going to be hard to really mix that up well. And then you're supposed to take a sample out of that is the required amount, which is going to be about 1 cup of material, about 300 cubic centimeters or something of material. And that's supposed to be the sample. I think there's a systematic error involved with that because people are not consistent about doing that. And so that's the standard method, which I've just described. It's also quite time consuming. If you think, I want to go sample 6 of my putting greens, well, that quickly becomes 72 subsamples that you have to pull out of the ground and then mix up. And then you're drawing that subsample out of there. That's an extra step where things can go wrong. What I like to do now is just take a single core and have that single core be enough material to run a test on. And now we know exactly what we are working with. So that's the kind of provocative and scary information you can get from that secret newsletter that I mentioned. So I've got code on my computer that makes the calculation for the average in two different ways, based on whether you've submitted composite samples or whether you've done the single core method. And this is another thing, Doug, that I have a bit of data on, and I should write articles about it, because when I do simulated fertilizer recommendations for turf grass, we get the exact same result. But now we've eliminated that potential source of subsampling error. So
Sure. Yeah, we're doing similar work too with organic matter, which we talked about. Organic matter is going to influence your nutrient levels, and we're trying to figure out how, if you're going to sample your putting green for organic matter content, how many subsamples might you need? And
yeah,
it depends a lot on the size and the shape and the topography of the green. But in general, what we're seeing, to minimize the amount of variation, or to get a good average that we're confident in, um, at least 20 samples in most cases. Some cases 10 will do it, but between 10 and 20 for sure. So it's interesting to think about just taking a single core and what the implications for that are, knowing the amount of variability that you can have across the surface. So yeah, there's a lot to think about there.
yeah, there's a lot to think of, and this should be quite a controversial topic, because you can make a really strong argument against what I'm suggesting is a possible way to do it. So for organic matter testing, for the OM246 testing, I still recommend taking multiple samples. So I don't recommend taking a single core there because that's too variable. But yeah, it's this is something we can talk here at the very end, where only the diehard people are still watching or listening, and you can hear about some stuff that's kind of some active research, because I don't want to recommend that everybody in the world goes out and just takes a single core and makes fertilizer decisions based on that. Then I don't recommend making fertilizer decisions based on a single core. I'm saying we're taking multiple single cores. Generally, for a set of 18 putting greens, I recommend testing 6 of them. So we would go take 6 cores, and then I'm assuming that those are not normally distributed. I fit a log normal distribution to that. And then from that, we can calculate the geometric mean rather than uh, the usual mean, the arithmetic, where you add the numbers together and divide by the number of numbers that you've added. That assumes that everything is distributed in the soil evenly, but it's not. The phosphorus is not. You get these high spots, and actually, I think in turfgrass sometimes it could be reversed, that you also get these depleted zones of the nutrients, and so the sampling is something that is very interesting, because I think there's probably some error in there, that maybe over the next upcoming years there will be more research in turfgrass, with people are looking at more precision turf management. I know there's companies out there doing all this GPS testing, and Helena has some kind of product that, or technology, where they pull soil samples, and then I sup- I don't know. I've just seen pictures of it, where they make spatial recommendations for fertilizer. So I'm not sure how that's all done, but I think there are some opportunities to do do better.
Yeah, I mean the takeaways are: don't overemphasize the individual values, look for trends. You know, If you're increasing your nutrients, that you might ask, why are we doing that? Are we increasing them on purpose, or is it because we're maybe over applying? If your numbers are going down, are you comfortable with that? Are you above the MLSN? Do you want to bring those down? And then, of course, once you reach a level where you're comfortable, your goal is to keep it stable. So I think about soil testing as a long-term strategy instead of a reactive. Take the sample, then adjust. And I think probably the average soil tester user does it like that, and that's kind of how the reports are set up. They'll actually tell you you need a very specific amount of fertilizer to add based on this result, and that's just not the way that I've chosen to look at those numbers. And I know that you feel mostly the same way about how to use those data.
Yeah,
So I get a little nervous with the spatial stuff. Like, oh, are we gonna be putting a little bit of potassium here and none there? It just seems like over management. In a way we need to conserve our resources and minimize our costs and increase our economic efficiency. And to me, that doesn't sound like a very good way to do that. For nitrogen, though, it sounds good to me.
Yeah, I suppose that will be an active research area for many years, especially when people try to use drones and so on to try to predict what may be required. And I know Bill Kreuser's been using some, and his grad student was using some growth monitors, right? With the, or was it sensors? Or they do everything. Yeah, I mean they measure the spatial growth differences and the some reflectance stuff.
Right. So you could base I think they were using NDVI or NDRE, which is a reflectance-based sensor mounted on a fairway mower. And then once the area was below a threshold, that would be add some nitrogen, and they can use a GPS sprayer to just add the nitrogen in the parts of the fairway that were below that sensor threshold. And I think I'm not sure what Helen is doing, but I think the nitrogen management makes more sense on a spatial variability scale than phosphorus and potassium soil nutrient management.
I'm going to just close by saying one more thing is another important thing to do is keep track of how much fertilizer you're applying. And so you need to really to understand your soil test results, you need to know how much of every element was applied between your previous soil testing event and the most recent data. So then if the soil test number is going up or going down, or if it's staying consistent, you need to know how much you've applied so that you can then adjust how much you apply going forward and know how that is likely going to influence the amount that's available to the plant. So it's pretty simple, but there are some things that can go wrong, and I would encourage everybody to pay attention to those things that we've highlighted that you really are non-negotiable if you want to make sense of the results. All right. Anything else, Doug? Before we go, I kept you a little bit longer than I initially thought, but like I said, I could talk about this all day.
Nope, I think we hit everything. Be consistent with your depth. Choose the Malic 3 extractant if you're able. If you're not, be consistent with what you have, and don't overreact to those numbers.
Perfect. That is wonderful. Thank you so much for joining me on the ATC Double Cut, Doug. And I hope that we will have a chance to talk about some related topic again in the near future, because we have similar interests about turfgrass.
Excellent. Thanks, Micah.
All right.
Can't wait.
Thanks a lot. All right. I'll sign off, everybody. For ATC from Bangkok, Thailand, I am Micah Woods.